So let's look for a moment at ARM's physical IP platforms. We divide our platforms into three major sections because they tend to have different requirements. At the left side, in the advanced technology range, this is processes from 32 nanometer and below. ARM is the only provider in the industry with support for every foundry process at 32 and 28 nanometer in high-K metal gates. That's 8 platforms in total, spanning TSMC, UMC, Global Foundries, and Samsung, the latter two being part of the Common Platform Alliance. In the middle, we have 15 platforms ranging from 40 nanometer to 65 nanometer. This is an area we call ramping technology. And we call it ramping because even though the mainstream designs have been in 65 and 40 for a long time, there are so many companies now reaching 65 and 40 in their designs that the number of designs is really taking off in the industry. And we see that growth will continue in the near future. Finally, on the right side, we have the mainstream platforms, which is 90 nanometer through 250 nanometer, with 69 mainstream platforms so far. These span a broad range of platforms from general purpose to specialty processes, things like high voltage, ultra low leakage, embedded flash, or other specialty capabilities. So no matter what your application in this sector, there's probably a process and an ARM Artisan Physical IP platform to satisfy your needs. What's exciting about these product lines is that many of these platforms are sponsored by the foundry and are available for your use for free with no license fee. Let's look next at the processor optimization pack roadmap I mentioned a moment ago, which is ARM's newest successful product. This comes from the realization that using generic general-purpose physical IP to implement your ARM core may not get the optimum results. And our customers have continued to ask us for more and more support in achieving high-performance ARM core implementations. A processor optimization pack is a complete solution beginning with 3 components. First, it contains ARM Artisan Physical IP custom tailored at a particular core, such as A9, particular process, and a particular foundry. We optimize that IP in close collaboration between the physical IP team and the processor team to directly target the critical paths of the CPU and also achieve high performance and low power. When we're done with that collaboration, we then produce a detailed benchmarking report that shows exactly what we're able to accomplish, so you understand what's a reasonable expectation to achieve with your design. And finally, and maybe most importantly, then we give you detailed implementation knowledge in the form of a user guide. These are very detailed guides that show you how to achieve those same results in your design. The combination of the 3 forms a complete solution for implementing your ARM core. POPs are available today across a range of cores from A5 to A9 and soon A7 and A15. And they're available on a range of foundry processes between 40 and 28 nanometer at Samsung, TSMC, and Global Foundries technology processes. Just to show you 2 quick examples, first, Panasonic recently rolled out a design using the processor optimization pack at 1.4 gigahertz on TSMC 40LP. Z-Labs showed a 1.5 gigahertz implementation on 40G with Cortex-A9. Both of these were able to get high time to market and high performance using the processor optimization pack. If you're interested in more information about this product line, there's a talk later in the track sessions that will go into more detail. It's also important to remember that ARM is not only investing in processor optimization packs, but is also upgrading our basic IP for leadership across the range. We're focusing specifically on our memory products as well to achieve extremely high density with our memory architectures at the leading edge, particularly to target the needs of reducing cost. Our new memory architecture, which is rolled out this past year, attacks cost in 3 important ways. First, it achieves very high density and thus efficient area. We see up to 33% smaller area with these compilers compared to the leading competition. That can save millions of dollars over the course of a high volume design. We've also attacked leakage power and see as much as 56% lower leakage power by using a better configuration, and that can reduce either package cost or eliminate the heat solution on your design, which can also save cost. Finally, by attacking test time, you can reduce test cost and remove that portion of your chip cost as well. These optimized memory products are available now, silicon validated, and available for 4 different foundries so far at 40 nanometer and 65 nanometer, TSMC, Samsung, SMIC, and Global Foundries. Now, I'm pleased today to announce to you something new we're rolling out just here in Taipei. You're the first people in the world to see this. In the interest of focusing very closely with our customers in Taiwan and assuring tight integration of ARM's processors, implementation, graphics capabilities, today ARM is announcing the opening of a new ARM design center in Taiwan based in the Hsinchu Science Park. This is a small design center, but focused on direct engagement with our customers at advanced technologies, beginning with advanced ARM processors, A7, A9, and A15, particularly targeted, our advanced graphics processors in the Mali T600 series, and ARM's advanced physical IP at 28 and 20 nanometers. This office will be a combination of existing ARM staff who have tight linkage with ARM's major design centers elsewhere in the world, and also new local staff, and will form in that way a close bridge between Taiwan and the Asia-Pacific market in general and ARM's offices in the rest of the world. So we're very excited for that announcement and glad to have a stronger presence here in Taiwan. Finishing finally at the top layer of the stack, with the software layer, ARM continues to invest in software as well. And as you've seen in Tudor's introduction, the ARM ecosystem for software continues to grow very rapidly. One result of the software improvements is increased system efficiency. But it also means that partners have more resources to draw upon for tools, operating systems, browsers, middleware, and plugins, making the ability to deliver an internet experience on an ARM-based device easier than ever. So I want to focus on a couple of examples in here. First is, ARM is working very hard to optimize for ARM cores, and we do that in a couple different ways. Last year, we announced a joint venture called Linaro, which is a joint venture with other key industry partners with the specific goal of targeting performance improvements on ARM and simplifying the ability to get ARM products to market more quickly. One of the goals of that was to drive performance improvements, for example, in the GNU compiler series, and we've achieved that goal. So far, we've rolled out over 10% performance gain in GCC results from the collaboration with Linaro. But Linaro also facilitates more rapid validation of ARM-based systems, and through Linaro's Linaro Automated Validation Architecture, or LAVA, and the ability to more quickly validate BSPs, board support packages for ARM, customers are able to get their designs into production more quickly and more easily. But ARM also works directly with the GNU suite as well. For the GNU compiler series, we've rolled out custom A15 pipeline optimizations to assure that GNU will do the right things for A15. We also have a dedicated team focusing on optimizations of the Cortex-M series as well. And those optimizations continue in contributions to the core, things like boot, coherence, and debug, and so on. Now, Android, you've talked a lot about Android today, has been a key focus in recent years, and we see over 600,000 Android devices shipping on ARM per day. The result, as Mike Rayfield mentioned, was millions and millions of devices based on ARM in the marketplace today and tens of thousands of apps. The ecosystem elements of this continue to grow with first the ARM Solution Center for Android. ARM has worked to roll out optimized components for Cortex cores, such as assembly code optimized libraries. Through the malideveloper.com portal, there's access to tools, content, and technical information to help you develop your systems. And through ARM's DS5 tool suite that I'll talk more about in a moment, there's the ability to optimize your system more easily for Android. So ARM develops tools optimizations in 2 different ways. First, I mentioned a moment ago about Linaro and working to optimizations there. But ARM also invests in our own DS5 developer studio as well. And DS5 contains a number of important contributions. First, of course, it contains ARM's highly optimized compiler. Second, it contains performance counter management, so that using the streamlined performance analyzer, it allows you to access the ARM performance counters and more easily tune your ARM workloads, especially for multi-core. Because if you've never done any kind of multi-core tuning, it's more complicated than single-core tuning. So this is a very important contribution. It also adds support, of course, provides support for ARM's platform simulation models, or FAST models, which allows you to rapidly prototype your systems before your silicon comes back. Finally, when you're using Linux and Android systems, it allows you to plug into those devices in the debugger and do more easier development. So in conclusion, we believe the ARM partnership brings strength and diversity. ARM devices allow you to serve a broad range of markets, a wide variety of end products, and it's only getting broader. This on the screen here is just a very small sample of some of the customers who are developing leading-edge ARM-based SoCs. And as you can see, it's a broad range from embedded applications to car, to smart meters, to appliances, all the way up to the mobile phones and the leading-edge consumer devices we think about today. Instead of delivering a one-size-fits-all solution, we think the open platform offered by ARM allows diversity to drive innovation. Look at this example on the screen here. These are all devices that at some level are quite similar. They're all touchscreen, tablet, or phone-based devices. And yet if you look more closely, all of these devices target different vertical markets, different cost points, different ranges of performance, and different end-user goals. And we believe this benefits you, the ARM partners, and it benefits the consumer, because you can target the consumer market you want to go after, and consumers have choice about the kinds of devices they want to purchase. So more and more, we believe the SoC is the system. We hope ARM is enabling these smarter systems through a range of integrated, collaborative technologies that work together and are proven together to accelerate your time to market. We think this architecture will address the needs of today and the needs of tomorrow, ranging from consumer devices all the way to intelligent embedded devices in the Internet of Things. And we think Flexible's SoC solutions in diversity is a strong result for you and for the marketplace. We want to thank you for your attention and thank you for your support of the ARM partnership. 谢谢。
热烈掌声，谢谢 Dr. John Heinlein 的精彩演说。